In Tableau, you can use the Explain Data feature to explore and evaluate individual marks in your data. When you use Explain Data, Tableau provides potential explanations for the selected mark. You can even open explanations in a new worksheet to explore your data more thoroughly. Before we look at using Explain Data, it's important to know the criteria for when it's available. Firstly, you must have permission to edit a view in Tableau Desktop to use Explain Data. The view must also use a measure that is aggregated with sum, average, count, distinct count, or aggregate. In our view, sales is aggregated with sum. The data must also be drawn from a single data source. Explain Data does not work with blended data sources. Explain Data is a good starting point for asking questions of your data. In our view, we can see that sales dipped in 2014 for the South region. We can use Explain Data to ask why. Select the mark, then select the light bulb icon to open the Explain Data dialog box. Alternatively, you can right-click the mark and select Explain Data. Note that you can only select a single mark. Multiple mark selections are not supported with Explain Data. The Explain Data window is made up of different parts. Along the top, we can see displayed the selected mark, 2014 South. Hovering over this also displays further information about the mark. Just below this, we see the measure in use, which behaves like a tab. If multiple measures are available, they will appear here as separate tabs. Below this, we see the expected value summary. This displays whether the value is expected or not. As you can see in our case, this value is lower than expected. Hovering over this will display details about the expected range. Statistical analysis is run on the aggregated mark when you use Explain Data. A model is built to predict the value of the mark, which then determines whether the mark is higher or lower than expected. The left side of the main portion displays the list of explanations. In our case, Explain Data is offering two explanations: the distribution of values for state and a lower number of records than expected. Explanations are listed based on how informative they are. Simple explanations with less variability take preference and so appear first. The right portion will display a description of the selected explanation with a combination of text and vizzes. You can open an explanation as a new worksheet with the top right icon. Once satisfied with Explain Data, you can close the window with the top X icon. We can now examine this avenue of analysis further thanks to Explain Data. You should use Explain Data as a starting point for analysis. As helpful as it is, however, note that it can't tell you what's causing relationships or how to interpret data. That's up to you. When using Explain Data, you should keep the following in mind. You need to use granular data that can be aggregated, i.e., your data must be granular, but the marks you select must be aggregated at a higher level. You should also consider the shape and size of your data. Tableau needs data containing enough marks to be able to create an effective model. Lastly, correlation doesn't imply causality. If there's a relationship between A and B, then A isn't necessarily causing B. Keep these in mind when working with Explain Data. This has been a basic overview of using Explain Data in Tableau. In Tableau Desktop, you can use multiple diversified measures in the same view. You can place measures on the same pane or create dual axes for differing number formats. For this demonstration, we'll be looking at the rate of change for multiple measures and consequently comparing them. As you can see in the data pane, we have multiple measures available. To start, I'll just right-click and drag Order Date to Columns, select Continuous Month, and click OK. We can now begin adding our measures. Let's start by placing sales on the rows shelf. Say we wanted to compare the rate of change in sales to that of profits. We just need to drag profit to the view and place it on the axis. Release your mouse when twin ruler icons appear. Doing this will automatically place the Measure Values pill on the rows shelf. This is a default generated field containing the values of each measure. Note the Measure Values card, which contains our sum of sales and profits. Also note the measure name pills on filter and color. This is also a default generated field that contains the names of each measure. These allow us to blend measures. As a result, we can compare the rate of change between sales and profits in the same pane. We can compare profit and sales in the same pane because they share the same number format. However, if we wanted to include another measure with a different number format in the view, we should place it in a new pane. Say we wanted to include profit ratio and discount in the view. To create a new pane for a measure, simply drag it to the rows shelf. Let's add profit ratio. We now have two panes. Note the axes for each pane. The first is formatted with standard numbers, while the second is formatted with percentages. Let's add the discount measure to this pane to compare the profit ratio and average discount. To do so, we'll need to create a dual axis. Drag discount to the right of the second pane and release when a dashed line appears. Note that you may need to change the aggregation. In our case, we need to change discount from sum by clicking it and hovering over measure to average. Because profit ratio and discount share the same format and a similar range, we should synchronize axes. Right-click an axis on the second pane and select Synchronize Axis. This allows for a more accurate comparison. Now that we've added our measures, we can clean our view up a bit. Because the second pane has been synchronized, two axes are unnecessary. We can hide an axis by right-clicking and selecting Show Header. We should then rename the remaining axis. Right-click it and select Edit Axis. We should then rename it to Profit Ratio and Discount, so it accurately portrays the measures used in the view. Click X to close this window. We have successfully created a view with multiple measures using measure values and dual axes. Note that you can add as many measures to the Measure Values pane. For example, we can place quantity in the Measure Values shelf, and it will appear in the view. However, note that a dual axis chart can only contain two measures. This has been a basic overview of managing multiple measures in Tableau Desktop. In Tableau, you can combine multiple worksheets to combine them in a dashboard. Dashboards are a good way of showing the overall picture of analysis in one place. Tableau also allows you to add interactivity for the end user. So, as you can see, we already have a workbook with multiple worksheets. We can combine these in one place with a dashboard. To create a new dashboard, select the New Dashboard icon at the bottom navigation bar. Note you can also create dashboards from Dashboard on the menu bar. Creating dashboards is similar to creating a view. You drag items from the left pane to the main view. There are a few different elements here, but for now, let's just focus on size and sheets. It's important to configure size before you start creating your dashboard, as this will affect how any worksheets appear when placed in the view. Let's open the drop-down menu, and then open the second drop-down menu, and set this to automatic so Tableau will adapt the overall dimensions based on the screen size. Any worksheets contained in the workbook will be displayed beneath the Sheets heading. Hovering over these will display a preview of each. Just drag the worksheet you want to incorporate to the main view to begin creating your dashboard. Let's bring some more worksheets into our dashboard. Again, simply click and drag from the left pane to the main view. However, because we already inserted a worksheet, we need to choose where to place our second sheet in relation to the first. Note the grey preview indicating we can place it to the left, above, right, or below it. Let's place it below. Let's incorporate one more sheet. Again, just click and drag from the left pane to the main view. Let's place this one beside our average discount sheet. When you place a sheet in a dashboard, it's held within a container marked by a surrounding border. You can select the sheet by clicking a blank area, which will also highlight the container. Also note that any cards displaying supplementary information would appear in their own container to the right. We can use these containers to manipulate how sheets in our dashboard appear. Let's resize our map container. Select it, then click and drag the bottom border when the cursor changes icon. We can rearrange containers too. Say we want to place the average discount sheet on the left. Click and drag the above handle and release when the grey preview covers the left sheet entirely. Each container also has extra options that appear to the top right. You can remove the sheet from the dashboard, jump to the worksheet itself, and choose to use the selected sheet as a filter. Let's use this map as a filter. Using a sheet as a filter can give the end user more interactivity by allowing them to focus on specific elements. For example, if we select a state, note how other sheets update to reflect this selection. Simply click a blank area to clear the selection. It's a good idea to make functionalities like this as clear as possible for the end user. We can do this with objects. Objects can be used to add visual elements such as images, or extra interactivity such as embedded websites. However, we just want to add text. Before we do this, I'll just set the dashboard to floating. I'll scroll down and select floating. This means we will be able to place objects freely, then drag text from beneath objects and place it in the dashboard. We then need to type and format our text. I'll then format this by selecting it, making it bold and larger, and align it to the middle. Click OK to finish editing text. This makes it easier for end users to use your dashboard. This has been a basic overview of creating dashboards in Tableau Desktop. Because dashboards are made with the intention of sharing, it's important to correctly manage layouts for varying devices. Tableau Desktop allows you to create custom layouts for desktop, tablet, and phone devices, giving you control over the end user experience. At the top of the dashboard pane, we have our layout options. Device layouts appear here beneath default. Unless specified otherwise, each device layout will contain every item and take its size and layout from default. Any item or element must first exist in a default dashboard if you want to add it to a device layout. By default, phone layouts are added to new dashboards, which is why phone appears here beneath default. If we go to dashboard on the menu bar, we can see add phone layout to new dashboards is toggled. This is why it appears here by default. Also note the option to add phone layouts to existing dashboards. Let's close this for now and return to the view. Note the lock icon indicating that this is an auto-generated layout, meaning that changes made to the default dashboard are automatically reflected here. As you can see in the view, the layout has been automatically adjusted to fit phone dimensions. If you want the phone layout to behave independently from default, select the lock icon. We can now make changes to the user experience on a phone. Note the square rectangle marking the user's visible section. For example, let's create some white space between the average discount map and average discount list with a blank object. I'll just scroll back up a bit. Drag blank from beneath objects and place it between the two sheets. We can then adjust this to make it slightly larger, to increase the white space between these two maps. This will make scrolling easier for mobile users. Because we set phone layout to independent, this blank area won't appear in default. If we return to default, we can see the blank object hasn't been inserted here. Let's look at creating more custom layouts. If you want to create custom layouts for desktop and tablet devices, you'll need to do so manually. To do so, select Device Preview on the dashboard pane. This will activate a toolbar above the dashboard. Using the arrows, we can cycle through the different layouts. You can view how the dashboard will appear in different models from the Model menu. This menu shows different monitor configurations, including Generic, Medium, Large, and iPad Pro. And you can switch between portrait and landscape orientation with the icon just to the right on the toolbar. Select Add Desktop Layout to add a custom layout for desktop devices. Note that desktop now appears beneath default on the left dashboard pane. Let's navigate to another device type via the toolbar. Once again, note we can change the model and orientation. For mobile devices, you can choose to display the dashboard as if the user were using the Tableau app. With this checked, the preview frame will be adjusted to leave space for app controls. We'll leave ours checked. Let's add an independent tablet layout by selecting Add Tablet Layout. Once again, note Tablet now appears beneath Default in the left dashboard pane. Creating a custom layout for each device gives you the most control over the end user experience. If you publish a dashboard with all three layouts, users will see their respective device layout rather than the default layout. Let's look at how we can optimize user experience for tablet layouts. Beneath Layout, select Custom. I'll just scroll down a bit. This will display any elements we can add along with the standard list of objects. If an item has a blue check beside it, it means it's being used in this layout. Because we have more space in a tablet, let's add a text object. Scroll down, select Floating, and then drag text to the view. Insert your text, and I'll just format it, making it bold, bigger, and middle aligned. Click OK to finish editing your text. And I'll just rearrange this so it's easier to see. If we return to the left pane and look at size, we can adjust how different elements will appear on this device. Selecting Default will mimic whatever the default dashboard is using. Fit All will automatically resize all items to fit the device frame size. Fit Width will automatically resize items to fit the width of the device, but the height is fixed. This is recommended for phone layouts. Note that these same customization options are available for the desktop layout too. Knowing how to optimize your dashboard for a variety of device layouts is essential to know if you plan on sharing your dashboard. We've now seen how you can manage dashboard layouts in Tableau Desktop. In Tableau, parameters are dynamic values that can replace constant values in filters, sets, calculations, and reference lines. They can be used to greatly increase the interactivity of your visit. We look at the different ways you can use parameters in this video. As you can see, we have a scatter chart showing profit by sales, with each mark representing a state. We want to give the end user the ability to filter the top number of marks in the view based on profit. We can do this with a parameter. To start, select the Data pane drop-down menu and select Create Parameter. From here, we need to name and configure our parameter. Let's firstly call this Top States Profit. Beneath Properties, we can select the data type. The option you choose here will affect how the parameter can be used in the workbook and its display options. Because we want to see the top n of states, we'll select Integer. You can set the current value and change the display format. Before creating your parameter, you'll need to configure the allowable values. We have three options: All, which will allow the user to insert any number; List, which allows users to select values from a list. Note the option to add values from a field. Range is only available for numeric data and allows users to set a range of values and the step size. We'll toggle minimum and maximum. Leave minimum set to 1 and set maximum to 50 because of the number of marks in the view. Click OK to create your parameter. Once created, any parameters will appear in the Data pane. We should open the drop-down menu and select Show Parameter Control so it appears in the view. We can use our parameter to select any number between 1 and 50 with the slider. However, in its current state, this makes no difference to the view. This is because the parameter hasn't been incorporated into something else. This is the key to understanding parameters. They simply control a variable's value. In this case, the variable is any integer between 1 and 50. Let's use this parameter with a filter to give it interactivity. We want to filter by state, so I'll just control-click our state pill and place it on the filters shelf. Select Top, and then toggle by field. Instead of filtering the top 10, we want this to be a variable. This is where our parameter comes in. Open the drop-down menu. Note the option to create a new parameter from here too, and select the parameter, Top States Profit. And we want to filter by sum of profit. We are essentially asking Tableau to filter the top states by profit, where the number selected with the parameter control will display the amount of states. Click OK to create the filter. So now, if we adjust the parameter, we can see the filter updates to match the variable. This is a very basic use of parameters. What makes them so dynamic is their ability to drive multiple elements. For example, we can have the variable figure displayed in the title. Double-click the title, and after top, open the Insert drop-down menu and select the parameter. And click OK. So now, if we update the variable, we can see changes in the view. We have 27 marks, and our title now reads Top 27 States by Profit. Parameters can also be used in calculated fields. Let's move to the next worksheet and see how. To demonstrate this, we will create a parameter that allows users to change the dimension being used in the view. We'll start by creating a parameter. Open the Data pane drop-down menu and select Create Parameter. We'll name this Select Dimension, set the data type to string, as we want to select from text, and toggle List. In the below list, we then need to insert values a user can select with this parameter. I'll just rearrange this window before we continue. We'll insert region, ship mode, and subcategory to the values column. You can change how these get displayed in the parameter itself in the Display As column. We'll leave ours as is though. Once again, note the option to add from field. We can also paste from clipboard here too. Click OK to create the parameter. We'll display it in the view by opening the drop-down menu and selecting Show Parameter Control. Like previously, the parameter is unfunctional because it hasn't been incorporated into anything. Let's create a calculated field we can include this in. Open the Data pane drop-down menu and select Create Calculated Field. We'll name this Calculation Dimension Selection. We then need to insert the calculation itself. We'll be using a case formula to find the value in the parameter, which will then return the corresponding dimension. So, when the region is selected in the parameter, then the region dimension will be used. We just repeat this for ship mode and subcategory. Always remember to end your calculation. Click OK to save the calculation. We can now place our calculated field in the column shelf, which gives our parameter functionality and allows users to select the dimension they want to see. Lastly, let's look at using parameters with reference lines in the next worksheet. We have a line chart showing the rate of change over continuous months for profit. We want to insert a reference line the end user can dynamically adjust. Once again, create the parameter via the Data pane. Let's name it Select Date. Set the type to Date. Change the current value. I'll change this to 2015, as that's when this data is from. And allow all values. Click OK to create the parameter. We show the parameter control via the Pill drop-down menu. Then switch to the Analytics tab to insert the reference line. Drag reference line and place it on month. Set the value to the parameter and change label to value. Let's quickly adjust the formatting so it's easier to see. I'll just make this line dashed, give it color and thicker, and click OK. Users can now set the date from the parameter. Just click the parameter, navigate to a date, select it, and the reference line will update accordingly. Parameters are one of the most dynamic functions in Tableau as they give end users much more interactivity. We've seen how to use parameters in filters, calculated fields, and reference lines, but this only scratches the surface of what you can do with parameters in Tableau. If you're using a table in your view, you can calculate the grand totals and subtotals easily in Tableau. You can even customize how these totals are calculated and where they appear. So as you can see, we have a table with various columns, rows, and panes. We can show totals if we go to the Analytics pane, Beneath Summarize, drag Totals to the view. This presents us with the options to calculate subtotals, which will calculate the totals of each pane, column grand totals, which will calculate the grand totals for each column, and row grand totals, which will display the grand totals for each row. Note that some of these options may not appear depending on your view. For example, if your table has only one pane, then the option to calculate subtotals will be grayed out. Let's calculate grand column totals by releasing our mouse over the option. As you can see, a grand total row has been added to the bottom of our table. Note that there are certain requirements needed for totaling to be available. The view must have at least one header. You can insert headers by placing a dimension on either the rows or columns shelf. Measures must also be aggregated. This aggregation determines the values used in the totals. Because our measure sales has been aggregated with sum, so too have the grand totals. Lastly, note that grand totals cannot be calculated for continuous dimensions. It's important to be aware of how Tableau calculates totals, as this may produce errors in your view. Let's move to the next worksheet and see when this may occur. Calculating the average. Let's calculate the totals on a row by row basis. I'll just drag totals and place it on row grand totals. Though this seems fine, the totals are actually incorrect. If we take the first row as an example and just open a calculator to compare, when you add central, east, south and west for the first row and divide it by 4, you get 487.11. However, the grand total displays 503.86. Let's minimize the calculator and investigate why this is. If we open the sales pill and hover over total using, we can see it's set to automatic. This means Tableau is averaging the data in the underlying data source, i.e. Tableau is deriving the result by averaging all values that contain the properties category equals furniture and subcategory equals bookcases and ignoring region. To amend this, we just need to select total using average. Selecting this manual option means Tableau will perform the totaling based on the values you see instead of the underlying data. And as you can see, our grand total is now being correctly calculated. By default, column grand totals appear at the bottom of the view and row grand totals appear on the right. You can change these if desired. Open Analysis on the menu bar and hover over totals. From here, you can move row totals to the left and if we navigate to the previous worksheet, reopen Analysis and hover over totals, we can place column totals to the top. This has been a basic overview of managing totals in a visualization in Tableau. Tooltips are a great way of showing additional information relating to specific marks in your viz. In Tableau Desktop, you can embed visualizations in tooltips. We look at embedding and then configuring visualizations in tooltips in this video. So, as you may already know, when you hover over a mark in the view, specific information relating to that mark is displayed in a tooltip. We can embed related vizes here to allow users to dig deeper into the data, but still maintain context. For this demonstration, we will be embedding our Sales Over Time worksheet into tooltips for our subcategory Sales worksheet. These are sometimes referred to as the target and source worksheets. Select the tooltip property in the source worksheet in the marks card. This will open the Edit Tooltip dialog box. You can leave the default tooltip text if desired, but we'll remove it for now with the delete key. To embed a worksheet, open the Insert drop-down menu to the top right, hover over Sheets, and select your target sheet, which is Sales Over Time in our case. When you embed a worksheet in a tooltip, it appears as such: the sheet name, max width and height, and filter level. By default, it's filtered on all fields possible and on the most specific level of detail. Click OK to save your changes and close the Edit Tooltip dialog box. So now, if we hover over a mark, We can see sales over time per subcategory embedded in the tooltip. We can configure the tooltip to change how data gets displayed and at what detail. Let's reopen the Edit Tooltip dialog box by selecting Tooltip from the Marks card. The default size for tooltips is 300 by 300 pixels. We can resize this by changing the max width and height figures manually. Let's increase the size to 500 by 500 pixels. Let's click OK and test our new tooltip. As you can see, our tooltip has been successfully resized. Note you should try to avoid making your tooltips larger than 600 pixels, as this will result in a crammed viz. As stated previously, tooltips are filtered on all fields possible and on the most specific level of detail. When we hover over a mark, we are seeing sales over time for that specific mark. We can change this from the Edit Tooltip dialog box. Say we wanted to see the sum of sales over time in total rather than at a specific mark level. First, clear all fields in Filter. Then open the Insert drop-down menu and select Sum of Sales. Note that you can filter more than one selected field by separating field names with commas. You can also filter on date level. However, you will need to include the string that specifies the date level with the field name. Click OK to save your changes. If we hover over our marks, we are now seeing the sum of sales in total regardless of which mark we hover over. To keep things clean, you may want to hide any target worksheets. To do so, just right-click the target worksheet, which is sales over time in our case, and select Hide. Note our tooltip still functions properly. To unhide a worksheet, just right-click a worksheet and select Unhide All Sheets. We've now seen how you can embed a tooltip to show sales over time, but you can also use embedded tooltips to show data at another level of detail, different but relevant data, multiple visits in one tooltip, a legend for the main view, and much more. You can add extensions to dashboards in Tableau Desktop. Extensions can quickly and easily give your dashboards unique features. Adding an extension is as simple as adding any other object. So as you can see, we have already created a dashboard showing the average discount and profit over time. We can add an extension to give this more interactivity. To add an extension, just click and drag extensions from beneath objects on the left pane and place it in the view. Once you release your mouse, you will be prompted with the following message asking you to choose an extension. You can open the extension gallery, which will open the default browser on the extensions gallery page, or if you have previously saved an extension, you can locate it by selecting My Extensions. Let's look at the extensions gallery. This will open a web page with a list of available extensions for Tableau dashboards. These are created by third-party developers to help expand dashboard functionality. You can select an extension to view further details, including a description and screenshots. And you can download it with the download button. Note the file extension is .t/ex. Let's minimize this window and return to Tableau. As stated previously, we can access any saved extensions by selecting My Extensions. Navigate to the .trx file you want to use. I have one saved from earlier here in this extensions folder. Select it and click Open. What happens next will naturally vary depending on the extension you've chosen. You may need to allow or deny access to data in the workbook. In our case, this extension provides interactive data filtering with brushing, so we need to configure some things before it's inserted. We need to select a sheet, which for us is profit over time, a date dimension, which is month of order date, and the measure, which is sum of profit. We can also adjust the formatting from here. Scroll down and click Save to insert the extension. I'll just quickly readjust things so we can see our extension and profit over time worksheet. This extension works by allowing users to filter a range of data with brushing like so. Note how the profit over time worksheet reacts to this change. We've added an extra level of functionality and interactivity with a few simple steps rather than creating this manually, saving us lots of time. Note that extension objects will appear blank in prints, PDFs, and images of dashboards. Depending on the extension, you can configure its options to change how it behaves in your dashboard. Open the Extensions Container drop-down menu and select Configure. In our case, this opens the same dialog box seen previously where we can alter the filter settings. Naturally, these will vary depending on the extension. Let's close this with the X icon. If your extension stops functioning, you may need to refresh it. You can do so by opening the Extension drop-down menu and clicking Reload. If this doesn't work, you may need to remove it from the dashboard and then add it again. Because extensions interact with data using a JavaScript library, you'll need to ensure that JavaScript is enabled. We can do this by opening Help from the menu bar, then Settings and Performance, then Set Dashboard Web View Security, and from here you can see Enable JavaScript is checked. This has been a basic overview of using dashboard extensions in Tableau Desktop. You can export your data to another application in Tableau Desktop. You can export from the data source page or from the view. You can also choose what format you want to export as. We look at the different ways you can export data from Tableau in this video. Firstly, we look at exporting from the data source page to a CSV file. CSV files are supported by a wide range of tools, databases, and programming languages, so using this format is a good way to share your data. As you can see, we are on the data source page. To export data from here, simply select Data from the menu bar and select Export Data to CSV. Then you simply need to name your dataset. We leave our set to order sample, choose its save location. Note the extension .csv indicating that this will be saved as a character delimited file. Click Save to export your data. If we then navigate to the save location via the File Explorer, we can see our data has been successfully exported as a CSV file, meaning it can now easily be shared. Let's close this for now and return to Tableau. We can also export all our data from the view. Let's navigate to the worksheet and see how. On the data pane, select the View Data icon. From this window, select Export All to the top right. This will open the Export Data dialog box where you can configure the file name and location. We'll select Cancel for now though. And I'll just close this window with the X icon. If you don't need to export your entire dataset, you can choose to export only data used in the view. This is handy as it allows users to generate the same view. When you export this way, the exported fields come from the fields on the shelves. In our case, it's region, state, and sum of profit and sum of sales. To begin exporting, select Worksheet from the menu bar, hover over Export, and select Data. Once again, the File Explorer will open. You will need to specify the name and location. Let's call this Sales v Profits. Note the file type, Microsoft Access Database. When exporting this way, you must export as a Microsoft Access file. Click Save to continue. If you're using Windows, the Export Data to Access dialog box opens where you can choose to immediately use the new Access database, which will allow you to continue working without interrupting your workflow. Click OK to export your data. If we then open the File Explorer, we can see our view has been successfully exported as a Microsoft Access file. As you can see, the data used in the view in Tableau has been successfully exported as an Access file, meaning we can share this with others, allowing them to regenerate the view. Let's close this for now. And our File Explorer. This has been a basic overview of exporting your data to a CSV or Access file in Tableau Desktop. If you're working with a view that has a large amount of marks, you might want to increase interactivity by turning on highlighting. Highlighting allows users to focus on specific marks while still maintaining the overall context of the view. As you can see, we have a scatter chart created with lots of marks, which makes it harder to interpret the data. We want to allow highlighting for state and subcategory so users have the ability to view specific marks. To show a highlighter for a discrete field, open Analysis from the menu bar, hover over Highlighters, and select your field. As you can see, the highlighter card for state now appears in the view. We can select the search box, and a list of possible options appears, or you can search for a term by typing. Select an option to highlight the members of this state. When you select a member to be highlighted, every other mark in the view becomes faded. This allows users to focus on specific data while keeping it in overall context. To clear the highlight, select the X icon on the highlighter search bar. An alternative way of showing a highlighter is by right-clicking a discrete field. In our case, we will right-click Subcategory, and selecting Show Highlighter. Once again, we can search for and highlight members of this field with the search box. I'll clear this for now. However, note that you can only highlight using one value set at the same time, i.e., we can't highlight a state and subcategory at the same time. If desired, you can choose to show labels for highlighted marks. Select the label from the Marks card, toggle Show Mark Labels, then beneath Marks to Label, select Highlighted. So now, if we highlight a state, mark labels will appear. Clicking a blank area will clear the selection. Highlighters can also be used in dashboards. Let's navigate to our dashboard and see how. If we drag our Sales v Profits sheet to the view, we can see our highlighter options appear on the right. Highlighters in the dashboard view are dashboard-wide, not just the sheet they were originally placed in. For example, if we search for a state, we can see highlighting takes place in all sheets with state members. This has been a basic overview of highlighting data in Tableau Desktop.